So this is in a nutshell, the essence of how we use the find contour. It is basically doing our detection for us. So we give it the binary quantized image and we get a list out called contours. And I hope you're familiar in Python, if you have a list, you can iterate on the elements inside the list. So if I had a list called students, and I said A for A in students, each time it would go through the list, A would be one of the students in the list. So CNT is going to be one of the objects in the contour list. So this is an object in the object list. This is a object in the list of objects it found with this contour program. So each CNT is an object. And now look, we're doing a function on the object. If you ask contour area of the object, it'll return the area. If you ask, give me the bounding rectangle of the contour, it'll return the coordinates. Okay, so CNT is an object in a list of objects from the find contour function. Okay, does that make sense? Good, I see one thumbs up, my buddy. Okay, I want more buddy. 2, one more, ooh, 3. Oh, I have 3 friends. Oh, that's great, goosebumps. All right, thank you, thumbs up. All right, so, okay, so I think we beat that one. So how many times is going to go through this? It's going to go through this based on the number of objects it found. And we found like 130 objects. So it's going to go through this a lot. And someone asked, why are you putting a count in here? Just as a way to keep track of what object it is currently looking at, to give it a number. Okay, so every time it goes through this loop, it's going to increase this count value. So we ask the object, what area are you? And give me a bounding box. It returns PO, which is an array of 4 values, and I just broke it out to be much easier to understand. The first 2 values are the top left corner of the bounding box, and the last 2 values are the width and height. And what CV2 wants is not width and height, but it wants the actual points. So to get the X0, Y0 is the top left point in the bounding box. To get the bottom right one, you got to take X0 and add the width. To get the Y of the bottom right point, you got to take the Y0 and add the height. Okay, so that took the coordinates that the contour program gave me and turned it into one that I can plot with the OpenCV rectangle command. Okay, but I'm not going to do that for everyone. I only like big objects because little objects I can't classify because they don't have much features. So instead of processing all those, I'm going to get rid of them. So I only pay attention to objects that have an area greater than minimum area. And one of your homework assignments is to vary this minimum area so you're only seeing blepharismas and to report that value. Okay, so we got the coordinates for the bounding box, and we're calling this CV2 routine called rectangle, which will draw a rectangle inside an image based on the bounding box you give it. And you can determine what color you want the rectangle and how thick the line is that draws the rectangle. So here's the rectangle command. We have to tell it what image we're going to draw in. We have to tell it the bounding box, the top left corner and the bottom right corner of the bounding box, and what color. And what order are these colors in, class?
BGR.
Beautiful, BGR. Blue, green, and red. Okay, and so what color is this going to be? Green, yes, very good. I see 2 greens. And what color is this? A 25500. Blue. And, you know, in general, it's bad style to put numbers in a function. It's because then, you know, someone reading like what does this mean? So that's why things like thick, instead of just writing 3 here or 2 here, I named it a variable and then I defined it up here. And my style is to all caps are for static values. Okay, so if you're greater than the minimum area, I'm going to draw a green rectangle. If you're less than minimum area, I'm going to draw blue.